Welcome to your final maths lesson of the week. Today we are doing correspondence problems. Here are the answers to today's mental maths questions. 9 times 11 is 99. 12 times 6 is 72. 91 times 10 is 910. 4,600 add 200 is 4,800. 2,000 subtract 800 is 1,200. 30 add 40 is 70. 1,000 more than 3,209 is 4,209. 50 add 950 equals 1,000. Double 45 is 90. And 8,666 is less than 8,999. In terms of mental strategies, to calculate 26 times 3, we can partition 26 into two numbers, 20 and 6. We can multiply them by 3 separately and then add the answers together at the end. So 20 multiplied by 3 is 60 and 6 multiplied by 3 is 18. 60 add 18 is 78. So our answer to 26 times 3 is 78. For the previous learning question, we know that 3,450 add 4,520 equals 7,970. So we know that addition is commutative. That means that we can switch around the two numbers that we're adding and they will equal the same answer. Therefore, 4,520 add 3,450 will equal 7,970. We also know that subtraction is the inverse of addition. Therefore, we can use these numbers in a subtraction. 7,970 is going to be the number we subtract from because it is the biggest number. So 7,970 subtract 4,520 has to equal 3,450. Likewise, 7,970 subtract 3,450 will equal 4,520. For today's oral starter activity, we are going to be counting in fives. Now, because I know you're all very good at counting in fives, I have to make it a little bit more challenging. So instead of counting forwards, let's count backwards. Let's do it together. 60, 55, 50, 45, 40, 35, 30, 25, 20, 15, 10, 5, 0. Now it's your turn to challenge yourself. Can you count backwards in fives? I've given you the first number for you, and I'm going to give you a generous 40 seconds to complete this task. Go! Time's up. I wonder how you got on. In today's maths lesson, we're going to be tackling some correspondence problems. Now this might be something that you're not all too familiar with. However, it might not be as tricky as you think. Correspondence problems are basically problems where you must find all possible combinations of objects in a set, or possibly in more than one set. Let me demonstrate. Here is an example of a correspondence problem. What we're looking to find out is how many different kinds of sandwich could you make. We have two types of bread, brown and white. We have three different kinds of filling, cheese, ham and jam. To make it work, we can only have one choice of filling. So what are our different options? Well, we could have brown bread and cheese, we could have brown bread and ham, or we could have brown bread and jam. If we chose the white bread, we could have white bread and cheese, white bread and ham, or white bread and jam. Those are our options. In total, there were 6 different combinations. 2 times 3 equals 6. Therefore, the answer to this question would be that there are 6 possible combinations. Here's another example of a correspondence problem. I wonder if you could solve this one yourself. Our question is, how many different outfits can you make? Your outfit will be made of a pair of shorts and a t-shirt. As you can see, there are 6 different coloured shorts and there are 6 different coloured t-shirts. How many different combinations of outfit do you think it's possible to make? I wonder what answer you came up with. Let's go through it together. Let's start with the yellow shorts. So you could pair that with the red t-shirt, the dark pink t-shirt, the light pink t-shirt, the orange t-shirt, the yellow t-shirt, or the green t-shirt. That would give you 6 different possible combinations. You can do that with the blue shorts. You could pair it with the red, the dark pink, the light pink, the orange t-shirt, the yellow, and the green. Do you see where we're going with this? Yes, all the shorts could be paired 6 times, 6 different ways. Therefore, the calculation we need to perform is 6 times 6, which we all know equals 36. Therefore, there are 36 possible combinations. Here is one last example to share with you. Our correspondence problem here is working out how many different kinds of ice cream you could make. You're allowed one sauce and one topping on each ice cream. So first of all, you've got to choose the kind of ice cream you want. You can either have vanilla, chocolate, strawberry, or mint. Your choices of sauce are either blueberry or raspberry. And finally, your toppings are either flake, sprinkles, or a wafer. So there are 4 different kinds of ice cream. So in our calculation, we need to have a 4. We're going to multiply that by the number of sauces, and there are 2 sauces. We're going to multiply the answer to that by 3, because there are 3 toppings. 4 times 2 times 3 equals... The answer is of course 24. 4 times 2 is 8, and 8 times 3 is 24. There are 24 different possible combinations. Me personally, I'm going for a mint ice cream with blueberry sauce and a flake. Yummy. It's now time to complete your independent work. As you do your worksheets, just remember, as long as you multiply one group by the other group, you can't go too far wrong. This is all about knowing your times tables.